So what exponent law can we use in this one? Add the exponents, subtract the exponents, multiply them, divide them. Guess. I love that exponent law. Bases are the same, so we're going to add them. When you add them, you get 0.6 to the negative 5. Now, what you might see on a test is there might be a question like this, but you get that answer and it doesn't match the answer on a multiple choice question. Because there's more than one way I could show this. What's another way that I could write the same answer? One over 0.6 to the 5, right? Because we could have our negative exponent law. So if it was multiple choice and this was the answer, we'd have to be able to know that I can use that negative exponent and change it. Could you see that on a multiple choice, can you change 0.6 to a fraction? It's 3 over 5. So another way this might show up is 3 over 5 to the negative 5. That's another equivalent expression. And this negative 5 could be the same as 5 over 3 to the positive 5. Now, if this was just a long answer question, we'd have to, again, focus on the instructions here. Write as a single power. We did that right here. This is a single power. A power has a base and an exponent. So we've done that if this was a question that was asking how to get a single power and it wasn't a multiple choice, that would be fine as a final answer. I'm not sure about your textbook. Some textbooks always like positive exponents and they'll change it in the answer key to have a positive exponent because a positive exponent is seen as simpler than a negative exponent. But for this, it would be fine to leave it as a negative 5. Again, we're using the same instructions from A, simplify and write as a single power. So we've got a combination of rules here. It's a decision, what do we do first? Here I have a power to a power. I can put those together by multiplying. So if I do that on both of these, and you have to make a decision here because the dividing will mean subtracting, which we can do now. But before we combine them as a single exponent, we can't really use the subtracting rule because the subtracting rule says when you have two powers that are divided by each other, then you can subtract. And we don't quite have a power yet because the first one is a power to a power. And same thing with the second one. So now that I've got one power divided by the other power, and both of them have the same base, we can subtract the exponents. What do we get when we do negative 12 minus negative 10? Negative 2. So we would technically be done, right? Because we have written it as a single power. So according to the instructions, and I'm trying to point out the instructions over and over again because on the last quiz, there was a big gap between what the instructions said and what people did. It's very important that you understand the instructions so that you can write it out properly. Because the same question can come up in different forms. This one says simplify by writing as a single power. I could ask this same question here, and instead of have simplify, it might say evaluate. Now, evaluate means get a final answer, and this would be a non-calculator question. This is one that you could do without your calculator. Now, right now at the beginning, you'd have to use your calculator. If you wanted to figure out each of these things individually, that needs a calculator. But once we've simplified it, we've got negative 2 over 7 to the negative 2. Okay, well that negative, so negative 7 to the negative 2, well that negative could flip our fraction, which would give us 7 over 2 squared. That's one option with dealing with the negative. Some of you might like the other option of dealing with the negative, where you put the negative to both things. I'll finish option 1 first, and then I'll finish option 2, and you can look at both and decide which one would you do. And I'm going to get you to give me some feedback on that. So if you use the negative to flip the fraction and then have 7 squared on top and negative 2 squared on the bottom, you'll get 49 over positive 4, because the negative squared would be positive. If you put the negative into each one, you would take an extra step to say the 7 with the negative 2 would move to the top of the fraction, and the power would move to the bottom of the fraction. Again, it's just the power that becomes positive. The base that's a negative 2 stays a negative 2. It's only the power, when you move the power, it's only the exponent that changes to positive. And then again, you get the same thing, 7 squared is 49, and negative 2 squared is 4. So on this evaluate one, now we've got a final answer. That's a fraction that can't be reduced. So that would be your final answer if the question said evaluate. Right as a single power, you could leave it like this, because you have written it as a single power. But if the question says evaluate, then they're looking for an answer in the end. Now on the evaluate section, this one on your left, raise your left hand if you would choose that method, right hand if you'd choose that method. Just curious. Okay.
Wouldn't you divide 49 by 4 just to get a final answer?
Well, if it reduced like that, but that is in lowest forms. Yeah. I mean, it's 8 1/4. You could write it as 8 point. No, it's more than 8 1/4. It's 12 and a. Yeah, it's 12 1/4. So you could write it as a decimal, although as we move up in mathematics, it's much easier to work with fractions than it is with decimals. So we'll often leave our answer as a fraction. So again, the instructions are simplify and write as a single power. Next example. Same thing, I'll just put up the answer. And then you guys, if you get something different, make sure you call me over. Yeah, I can make it bigger.
Okay, so that's like -1/4 exponent.
Yes. Oh, okay. I'll come there. Okay, so if we're problem solving here and I've got 9 to the 1/4, how many people thought of this? Excuse me. Okay, good. Right? It changes it to a radical. It doesn't help us with the fact that we want a 3, though. Okay, because we got the 4 through to 9. How many people recognized that 9 is the same as 3 squared? Okay, because that's something that you know. And the nice thing about changing it to a base of 3, it seems to connect to what we're trying to prove anyways. What can I do if I have 3 squared to the 1/4? I can multiply, right? Because a power to a power means you can multiply. And how do I multiply fractions? This would be 2 over 1. Multiply the tops, multiply the bottoms, and I get 2 over 4, which is 1 over 2. And now the same thing you used here with the 9s to get the 4th root. Now I have 3 to the half. That's the square root of 3.
Is there other ways of doing that? Can I do
Yes, if you went from here and changed the 9 to a 3 squared and then worked back and forth, you could do that as well. Another thing you could do, 9 is 3 times 3. Agreed? 3 is square root of 3 times square root of 3. So the second 3 would be square root of 3 times square root of 3. When you have a 4th root, you need 4 of the same thing in order to pull it out. Just like when we had 4 a's, you need 4 a's to pull 1 out. So here, I have 4 root 3's. I could pull 1 out, and I get root 3 as well. I think that's more confusing, though. I like the black the best. Simplify the following. Again, I'll get you to do it, then I'll give you the answer in a bit. A lot of people have written it this way, which would be fine, and full marks. Okay? Personally, as far as working with things later on, if you could write this as a single fraction, you'd have the 2 on the top, the 3 on the bottom. When things are simplified, you'd have x. You have 3 more x's on the top, so you'd have x cubed on top. And if you think about the y's, you have more on the bottom, which is just your negative exponent rule, moving that y to the bottom of the fraction. Later on, when you're simplifying expressions, sorry, I didn't need to make that line so long, this will be easier to work with than the top thing. Okay? I also saw some of you start to write your fractions like this, which is not wrong. But you're going to find that later on when you're working with big sets of fractions and big sets of numbers, writing it in this form at the bottom will make your life easier. Ready? Ready? I would like your answer to look like this in the end. Evaluate numbers if you can. So if you didn't get the 125, see if you can figure out how you would get that 125. Probably most of you had this, right? So how do you change this 25 to the 3 over 2? How do you change that to 125? And if you didn't get the a to the 6 and the b cubed, call me over because I'll come help you with that. Oh yeah, if you want to see how you change the 25 to the 3 halves to 125, I've put it up there. 3 more examples. So you can really start to see how those exponent laws from grade 9, you have to really know them, not just kind of know them. You have to know them really, really well, because you're going to be applying them with fractions and with negative exponents and all sorts of things. So you've sort of got to practice them a fair bit, because it's easy to make little mistakes along the way. Ready? Any more questions on this one? How many people were able to get that one before they saw the answer? Couple?
Actual question though.
Yeah.
What makes you decide to put the x to the power of 11 over 2 on the bottom for that fraction?
I said some textbooks will always have exponents written positive. It's not seen everywhere as most simplest form with positive exponents, but in some places it is taught that way. So just in case you get the top answer, which is fine, okay, but you look in the back of the book and they have this, it just reminds you of that negative exponent law. So it's a good reminder, and to see that both of those answers would be right. The negative exponent says whatever fraction part it's in, and technically here at the top, this would all be over 1, right? So everything's in the numerator. But that x to the negative 11 over 2 could get moved to the denominator and made a positive exponent. And that's what we have at the bottom.
And what would happen if
Well, there's technically still a 1 out there still, but 1 times anything is not necessary to write. You could write it there and it wouldn't be wrong, but we generally don't write. Last one. There are 2 different ways of approaching this, and both of them are right. One, however, will work out to give you simpler numbers, and the other one will work out to give you numbers that are a little bit more difficult. Okay? The easier way is to look inside your brackets. Sort of think of BEDMAS, because BEDMAS has brackets there. Can I simplify inside of my brackets? Yes, I can. So if I simplify first, I'm going to get 25. X squared and x to the 4 will give me x to the minus 2 if I subtract those exponents, and y to the minus 3 if I subtract those exponents, and I'd still have the half out front there. So that's simplifying inside the brackets first. It's not wrong to use the other exponent law and put the 1/2 in first and say this will be 50 to the 1/2, x squared to the 1/2 will be x to the 1, y squared to the 1/2 will be y squared, y to the 4 to the 1/2 will be y squared. You'd get 2 to the 1/2, x to the 2, and y to the 7 over 2. That's not wrong. Can you see that working on the left is going to be easier? If you simplify in the brackets first, you're going to make your life easier. So we don't always just go with, well, I know I can do this, so I'm going to do it. Sometimes you have more than one option, and you have to sort of, in your head, look at both options and then decide which one's going to create a simpler problem. In this case, this is going to be a lot simpler on the left. Now, when I put that half through, I get 25 to the half. Half times negative 2 is negative 1. Half times negative 3 is negative 3 halves. You can simplify 25 to the half is the same thing as a square root of 25, which gives you just 5. If you wanted to write, I mean, this is with negative exponents, or you could write it with positive exponents like that. Put up your homework assignment in a second. Ready?